Things are moving slowly but surely. Ah? Oh, is this me? Here I am. I'm alive. Hey, there we go. Right, where am I? Where am I? Let us get the chats in. Is that how I sound right now? I'm a bit sick, so sorry about sounding like that. Alright, there we go. Oh, you thought it was Monday? So did I, honestly. Seriously. It is Tuesday, right? Look, I'm a fool. Yesterday I thought it was Wednesday, and I thought I'd missed this, to be honest. Anyway, welcome in. Glad to see that. Oh, I just send. Right, here's chat popped up. Of course, if you've made other plans, not a worry, Sorbet. Glad to have you or not, whichever is the deal. Okay, are we ready to go? This is not where we were before. Functional language features, iterators, and closures. More about cargo and crates.io. That's where we were. We're starting this, aren't we? We'll learn more about crates. Again, apologies for the sound and the constant coughing or clearing my throat. I'm becoming ill. I'm okay with that. I like being ill. You planned on resting? That's always good. Well, I hope you have a good rest, Survey. Just a moment, gotta get one thing going. Oh wow, I'm jittering in and out of existence. He doesn't love that. I'm on a different plane. What if I just took that thing out? Yes. Nah. You see me better without this? Maybe, who knows? Okay. No. That's fantastic. I'll go like this. Hey, there we go. Just gotta stay really close. Okay. I think that's about it. I am just gonna start out reading. Of course, if you're not going to be able to be here, this is just about crates.io, so not exactly the most important thing to be here for. That's pleasant. I'm very glad that that happened. Right. Romeo. Oh, you're going to stay? Glad to have you. Okay. Well, isn't that nice? I have it in here, but I can't show you my clipboard history. So I'm going to hope I can get it back. No. Honestly, I have no idea what the problem is. This keeps happening. I'm using something called Florp currently, which is built off of Firefox. Seriously, it's never given me an issue before. This thing. Just Florp. Made by a Japanese guy. Never had an issue. Oh, wait, what is on there? I forgot that it had little things on there. And I just showed you that I'm into piracy. That sucks. Yeah, okay, so can we get this? It's not pasting. That's fantastic. Can I paste it anywhere? Yes, I can. Yeah, I love Florp. Florp is good. This is just regular Firefox, though, and it crashes like hell right now. Is it because of the zoom? It cannot be because of the zoom. I thought I had fixed the issue with this. I definitely haven't fixed the issue with copy and pasting. That must be a Wayland thing, because this is not my dev version. Neither is the Firefox thing. Well, maybe I did fix it in the dev version, but not here. Okay, what am I going to do? Is there a way to start from the command line? Start Chrome from the command line. On page. Because I'm not going to type that in. Or maybe I am. Fuck it. Let's just type it in. Oh, there is? I'd assume there would be. What's this take us to? Oh, well, of course Firefox says that. Apparently there is. Of course, I don't have Chrome.exe, but you know. What do I even have? It's called Chrome Driver. Okay. This is really cool if I can get this to work. Well, let's take out incognito. I don't need incognito. App equals. Let's just yoink this again. Hey, that worked. It doesn't have... Oh no. It doesn't have anything else on it. I actually like that a lot more. That's fun. I like that. That makes me happy. Okay. Yeah, I guess we can start now. We don't have the top of the browser anymore. That's gone now. We don't need it where we're going. Alright, let's start. More about Cargo and Crates.io. So far, we've used only the most basic features of Cargo to build, run, and test our code. But I can do a lot more. In this chapter, we'll discuss some of its other, more advanced features, and show you how to do the following. Customizing your build through release profiles, publish libraries on Crates.io, organize large projects with workspaces, install binaries from Crates.io, I think we've already learned that, and extend Cargo using custom commands. Okay, so Cargo is just NPM. I love that. Everything should have a package manager, and NPM is a great thing to copy. Love it. Cargo can do even more than the functionality we cover in this chapter. So for a full explanation of its features, see its documentation. What happens if I do this? It's going to open up in a new instance. Shame. Okay. First off to start, we're going to be doing customizing builds with release profiles. In Rust, release profiles are predefined and customizable profiles with different configurations that allow a programmer to have more control over various options for compiling code. Each profile is configured independently of the others. Cargo has two main profiles, the dev profile Cargo uses when you run Cargo build, and the release profile Cargo uses when you run Cargo build -- release. The dev profile is defined with good defaults for development, and the release profile has good defaults for release builds. These profile names might be familiar from the output of your builds. Cargo build, finish dev. Alright. So you have dev and release. Can we build both at the same time? I doubt that's a thing you can do. The dev and release are these different profiles used by the compiler. Cargo has default settings for each of the profiles that apply when you haven't explicitly added any profile.all sections in the project's cargo.toml file. By adding profile.all sections for any profile you want to customize, you overload any subset of the default settings. For example, here are the default values for the opt level settings in the dev and release profiles. Profile.dev, optimization level is at 0, whereas here, profile.release optimization level is at 3. So this dev build will only work on your computer, essentially, whereas this will work on any, but it will take longer. The opt level settings control the number of optimizations Rust will apply to your code, with a range from 0 to 3. Applying more optimization. Oh, no, this is an O level, as in like the regular C compiler then. I could have it wrong on that too. Alright, so if you're in a development and compiling your code often, you want fewer optimizations to compile faster, even if the resulting code runs slower. Okay, this is different than just like using CMake. Unless I have that wrong, I can't remember. I just have a script for that. The default opt level for dev is therefore 0. When you're ready to release your code, it's best to spend more time compiling. You only compile in release mode once, but you'll run the compile program many times. So the release mode trades longer compile times for code that runs faster. That is why the default opt level for the release profile is 3. You can override a default setting by adding a different value for it in cargo.toml. For example, if we want to use optimization level 1 in the development profile, we can add these 2 lines to our project's cargo.toml file. Profile.dev opt level 1. This can be very useful if you're building something that's data heavy, and every time you have to run it, it'll take more time to run than it will to compile, perhaps. This code overrides the default setting of 0. Now when we run cargo build, cargo will use the defaults for the dev profile plus our customization to opt level. Because we set opt level to 1, cargo will apply more optimizations than by default, but not as many as in release build. For a full list of configuration options and defaults for each profile, see cargo's documentation. A few other things that it will do, by my understanding, is it won't have debugging. Normally, when you compile with like C or C++, stuff like that, you'll have to tell it to add in the compile, to when it compiles to compile in debugging information. But it looks like Rust will do that by default on the dev profile, but will not do that by default on the release profile. I believe not. Let's start this though. When you run cargo build with no additional flags, which profile is being used by default? That is the dev. 1 out of 1. To minimize compile times, we understand this. If you want the release prof for longer compile times but faster code execution, there's no build profile. Okay, yeah, that's just saying there is no profile named build. Publishing a crate to crates.io. We've used packages from crates.io as dependencies for our project, but you can also share your code with other people by publishing your own package. Crate registry at crates.io distributes the source code of your package, so primarily hosts code that is open source. Rust and Cargo have features that make your published package easier for people to use and find. We'll talk about some of these features next and then explain how to publish a package. Make useful documentation comments. Accurately documenting your package will help other users know when and how to use them, so it's worth investing the time to write documentation. Chapter 3, we discussed how to comment Rust code using 2 slashes. Rust also has a particular kind of comment for documentation, conveniently known as the documentation comment, or doc block, in any other language. That will generate HTML documentation. I like that, that's good. The HTML displays the contents of documentation comments for public API items intended for programmers interested in knowing how to use your crate as opposed to how your crate is implemented. Documentation comments use 3 slashes instead of 2, and support markdown notation for formatting the text. Place documentation comments just before the comment they're documenting. Sorry, the item they're documenting. Listing 14.1 shows documentation comments for an add1 function in a crate named myCrate. Whenever I'm hired on for a contract, I usually go through all of the code and add doc blocks to them. They usually like that, sometimes they don't. Right, this is a massive amount of information for a very, very small function that is self-documenting. This is something that you really shouldn't be doing. Oh, and here's the documentation test that they were talking about before, which I really love. I love that this exists. Because you can just run this code, can't you? And ensure that it works the way that you want it to. I really do enjoy that. This is way too big for something that's self-explanatory, though you don't need all of this. Can you put in stuff like explaining the properties? Or gosh, what is it called? The stuff that you pull in. Can you explain X is the real question. That's what I hope, so that you can use LSPs to just pull that information. Here we give a description of what the add1 function does. Start a section on the heading, examples, and then provide code that demonstrates how to use the add1 function. We can generate the HTML documentation from this documentation comment by running cargo doc. This command runs the Rust doc tool distributed with Rust and puts the generated HTML documentation in the target/doc directory. So Rust doc is a tool distributed with Rust. Does that mean that we can just push that to stdl and then create our own little tool? That'd be pretty cool. If it just outputs HTML, we could use some regex to change the UI a bit, or to just add it onto a massive directory. For convenience, running cargo doc-open will build the HTML for your current crates documentation, as well as the documentation for all of your crates dependencies, and open the result in a web browser. Navigate to the add1 function, and you'll see how the target in the documentation comment is rendered, as shown in figure 14.1. And that looks really nice. I quite like that. I hate the UI on this side, though. That is disgusting. That looks really poorly done. Just this block, it's too slightly down. Look, that word is just a bit too far down for up here. I mean, that Y really doesn't help, but still. Even without that Y, like just the M is too far down from the top. On top of that, it looks boring, and it doesn't fit the stylistic choices you've made here. And also, why does it go over only this section? Like, you're not using tab style anywhere else. Like, come on. Apologies for complaining about that. This is ugly. This is really nice. I really like how they've done this section. HTML documentation for the add1 function. Commonly used sections. We use the examples markdown heading in our listing 14.1 to create a section in the HTML with the title Examples. Here are some other sections that crate authors commonly use in the documentation. Panics. The scenario in which the function being documented could panic. Callers of the function who don't want their programs to panic should make sure they don't call the function in these situations. There's also errors. If the function returns a result, describing the kinds of errors that might occur and what conditions might cause those errors to be returned can be helpful to callers so that they can write code to handle the different kinds of errors in different ways. Safety. If the function is unsafe to call, we discuss unsafety in Chapter 19, there should be a section explaining why the function is unsafe and covering the invariants that the function expects callers to uphold. Most documentation comments don't need all of those sections, but this is a good checklist to remind you of the aspects of your code users will be interested in knowing about. Okay, yeah, so that is simply done with hashtag space and then whatever single piece you want. parse rx function in CLI-ff returns result. Yeah, that would be a good place to write a doc block with an error section. Most documentation comments don't need all of these sections. Oh, we've already read that. Adding example code blocks in your documentation comments can help demonstrate how to use your library, and doing so has an additional bonus. Running cargo tests will run the code examples in your documentation as tests. Nothing is better than documentation with examples. But nothing is worse than examples that don't work, because the code has changed since the documentation was written. If we run cargo test with the documentation for the add1 function from listing 14.1, we will see a section in the test results like this, running one test from this section, add1, and it's fine. I really like this. This is fantastic. This is really good. I love that this exists, and I'm going to use it way too much. Now if we change either the function or the example, so the assert equal in the example panics and run cargo test again, we'll see that the doc tests catch that the example and the code are out of sync with each other. Can we have it so the code still compiles even if it faults? I guess... Oh, well, I guess it will. No matter what, just don't run cargo test. Commenting contain items. The style of comment, exclamation mark, adds documentation to the item that contains the comments rather than the items following the comments. We typically use these doc comments inside the crate root file, source lib.rs by convention, or inside a module to document the crate or the module as a whole. For example, to add documentation that describes the purpose of the myCrate crate that contains the add1 function, we add documentation comments that start with exclamation mark at the beginning of source lib.rs file, shown in this listing. Right, so we have //bang. The title is myCrate. myCrate within tildes is a collection of utilities, so on and so forth. This is just a description with a little bit of more information down below. This would probably be like some form of main page. Yep. Notice there isn't any code after that last line that begins with //bang. Because we started the comments with //bang instead of //, we're documenting the item that contains this comment rather than an item that follows this comment. In this case, the item is source lib.rs, which is the crate root. These comments describe the entire crate. When we run cargo doc -- open, these comments will display on the front page of the documentation for myCrate crate above the list of public items in crate, shown in figure 14.2. Documentation comments within items are useful for describing crates and modules especially. Use them to explain the overall purpose of the container to help your users understand the crate's organization. Yeah, this is really good for writing really reasonable documentation as you're programming, and I really hope that the projects I go to actually utilize this. Say you are publishing a library and want to write documentation about the entire library at the top of the lib.rs file. The documentation should be prefixed with the following comment syntax. I don't know. Hell yeah, quiz time? This one I think I got, though. Unless the next question is just abhorrent. It's just //bang. I wonder why that's called bang. Say you are creating a library worldly with the following function lib.rs. You have a doc block here, add string world to s. Example, here is an example, and here is the test. If you run cargo test, will any test fail? Right? So let's check this first. Let mutable s equals string new, worldly, add world, adding the mutable s, assert equal, s, and hello world. Yes, this will fail because it just pushes world to mutable s, so that'll just be world. That'll fail. Last one? Yep. That was a very short quiz. I'm not even going to read this. Yeah, this is just checking right here. This code test does pass. This fails. We're correct. Fantastic. Right, / bang is appropriate for module level documentation, while / is for documenting individual items like functions. Yes, this will fail. The incorrect example will be run as doc test and cause cargo test to fail. You don't even have to state that it is like something you got to test. It checked if it was equal to world. Oh, this one does pass. This pass is fine. This one will not pass, however, because it's hello world. Yeah, that's what they're trying to show. Perfectly understandable. I'm just really happy that I don't have to write like hashtag square bracket tests unsquared bracket at the start. This is already getting a bit much, to be honest. Like, this is 3 times the size of your actual function. Exporting a convenient public API with pub use. The structure of your public API is a major consideration when publishing a crate. People who use a crate are less familiar with the structure than you are, and might have difficulty finding the pieces they want to use if your crate has a large module hierarchy. Oh, that's such a funny joke, man. You think I'm familiar with my crate? No. Honestly, some random dude off the side of the street probably understands more about my code than I do. In Chapter 7, we covered how to make items public using the pub keyword, and bring them into scope with the use keyword. However, the structure that makes sense to you while you are developing a crate might not be very convenient for your users. You might want to organize your structs in a hierarchy containing multiple levels, but then people who want to use a type you've defined deep in the hierarchy might have trouble finding out where that type exists. They might also be annoyed at having to enter use migrate some module another module useful type rather than use migrate useful type. So I'm assuming that this is going to be like some alias. The good news is that the structure isn't convenient for others to use from another library. You don't have to rearrange, The good news is that if the structure isn't convenient, you don't have to reorganize. Instead, you can re-export items to make a public structure that's different from your private structure by using pub use. Re-exporting takes a public item in one location and makes it public in another location, as if it were defined in another location instead. Does that mean that it's available in both locations? I assume so. I see no reason not. For example, say we made a library named Art for modeling artistic concepts. Within this library, there are 2 modules. A Kinds module containing 2 enums called primary color and secondary color, and a utils module containing a function named mix, as shown in listing 14.3. Alright, here we have title Art, a library for modeling artistic concepts, with / bang that is describing the entire structure, which is sociallib.rs, the entire crate. Yet we have public mod kinds with public mod primary color, has all the primary colors, and a public mod secondary color. Within the module utils, we have use crate kinds, and a public function mix. Figure 14.3 shows what the front page of this documentation shows what the front page of the documentation for this crate generated by cargo doc would look like. Alright, we have art with some modules, kinds, and util. Note that the primary color and secondary color types aren't listed on the front page, nor is the mix function. You have to click kinds and utils to see them. Another crate that depends on this library would need use statements that bring in items from art into scope. Specifying the module structure isn't currently defined. Listing 14.4 shows an example of a crate that uses the primary color and mix items for the art crate. So you have use art, kinds, primary color. Use art, utils, mix. I have no issue with this, but it can get a lot worse as time goes on. The author of the code in listing 14.4, which uses the art crate, had to figure out that primary color is in the kinds module and mix is in the utils module. Okay, that's a good argument. Who would know where that was? That's fair. The module structure of the art crate is more relevant to developers working on the art crate than those using it. The internal structure doesn't contain any useful information for someone trying to understand how to use the art crate, but rather causes confusion because developers who use it have to figure out where to look and must specify the module names in the use statements. To remove the internal organization from the public API, we can modify the art crate code in listing 14.3 to add pub use statements to re-export the items at the top level, as shown in listing 14.5. So we have pub use, self, kinds, primary color, secondary color, and mix from utils. And here are the definitions we had previously. So there is a minor issue. This means that people can now just use mix, use secondary color, and use primary color from within the code without having the full piece. I don't see that as being as much of an issue as I originally thought, actually. A second of thought has changed my mind. The API documentation that Cargo Doc generates for this crate will now list and link re-exports on the front page, as shown in figure 14.4, making the primary color and secondary color types and the mix function easier to find. Right? Yep. So we still have the module section, but we have re-exports, which just actually has these pieces here. The art crate users can still see and use the internal structure from listing 14.3, as demonstrated in listing 14.4, or they can use the more convenient structure in listing 14.5, as shown in listing 14.6. You can just use art mix. In cases where there are many nested modules, re-exporting the types at the top level with pub use can make a significant difference in the experience of people who use the crate. Another common use of pub use is to re-export definitions of a dependency in the current crate to make the crate's definition part of your crate's public API. That is good. That is really good. It allows you to segment your application up more and more and more, and yet still preserve the convenience of having that all built into one singular project. From a user's perspective. I quite like that. That's good. Creating a useful public API structure is more of an art than a science, and you can reiterate to find the API that works best for your users. Choosing pub use gives you flexibility in how you structure your crate internally and decouples the internal structure from what you present to your users. Look at some of the code of crates you've installed to see if their internal structure differs from their public API. That is a good point, though. If you're ever looking to contribute to a Rust project, you really can't trust this for structuring. You have to trust the modules, though perhaps it's a way to look at the re-exports in a different way. I don't know if that is a good point, because personally I would look... No, I don't think I would, to be honest. No, I think this is really nicely done in a way that actually does show you where it exists, but allows you to just pick up primary, secondary, and mix by using art, : mix. That's good. Setting up a crates.io account. Not something I'm going to do right now. Before you can publish any crates, you need to create an account on crates.io and get a public API token. To do so, visit the homepage at crates.io and log in via a GitHub account. The GitHub account is currently a requirement, but the site might support other ways of creating an account in the future. That is good. I don't use GitHub unless it is forced on me. So no, I would not be contributing to crates.io. Unless they had like a ForgeGeo ability or some other private repository. Once you're logged in, visit your account settings at crates.io/me and retrieve your API key. Then run the cargo login command with your API key. like this. Cargo login, then this mess of characters. This command will inform Cargo of your API token and store it locally in Cargo credentials. Is this just in plain text? Note that this token is a secret. Do not share it with anyone else. If you do share it with anyone for any reason, you should revoke it and generate a new token on crates.io. You can share it with your organization. There are reasons to have that. Multiple people can't have access to that token. That's fun. Adding metadata to a new crate. Let's say you have a crate that wants to publish. Before publishing, you'll need to add some metadata in the package section to Crate's cargo.toml file. The crate will need a unique name. While you're working on a crate locally, you can name a crate whatever you'd like. However, crate names on crate.io are allocated on a first-come, first-served basis. NPM had a massive issue with a kick that led to, what was it, left pad? Anyone looking at this wants to research that. That was an insane thing that happened because they just kicked some guy off of their site due to the kick website wanting to just steal some guy's project name. It led to massive amounts of issues for the entire web. Before attempting to publish a crate, search for the name you want to use. If the name has been used, you will need to find another package name and edit the name field in the cargo.toml file under package section and use the new name for publishing like so. Here we are. Package name equals guessing game. Even if you've chosen a unique name, when you run cargo publish to publish the crate at this point, you'll get a warning and then an error. Warning: manifest has no description, license file, documentation, homepage, or repository. I'm glad they forced these things. That is good. Snip error. Failed to publish to registry at crates.io. This error? This errors because you're missing some crucial information. The description and license are required so people will know what your crate does and under what terms they can use it. In cargo.toml, add a description that's just a sentence or two, because it will appear with your crate in the search results. For the license field, you need to give a license identifier value. Linux Foundation Software Package Data Exchange lists the identifiers you can use with this value. For example, to specify that you're licensing your crate under the MIT license, don't do this. Add the MIT identifier. Be better than that. Use GPLv2. What are they? Oh dang, there's a lot of these. Actually, there's less than I thought. Yeah, are these just like accepted open files? Yeah, that's just accepted open source files, except for app style license. I don't know what that is. Okay, yeah, this is actually a very incomplete list. I guess these are the only accepted licenses? Can you not use a custom license? So you cannot use a custom license in a crate. That's not going to be great for companies. Companies are not going to love that. If you want to use a license that here it is, does not appear in SPDX, you need to place the text of that license in a file. Include that file in your project, and use license file to specify the name of that file instead of using the license key. Okay, that's a lot better. I am glad. So you can just use any license, like the free beer license. You can use this for any purpose for as long as you want, with no restrictions, as long as the next time you see me, you buy me a beer. I like that license. Guidance on which license is appropriate for your project is beyond the scope of this book. Use GPLv2. Many people in the Rust community license their project in the same way as Rust by using a dual license of MIT or Apache 2.0. Apache 2.0 is also a good license. This practice demonstrates that you can also specify multiple license identifiers separated by or have multiple licenses for your project. To have multiple licenses for your project. With a unique name, version, your description, and a license added, The cargo.toml file for a project is ready to publish and might look like this. All right, so we just got name, version, edition. What's GPL v2? MIT and Apache? Oh, dang, that's a very long description. MIT is essentially stating that I give you free use of this program. You can take the code, you can change it however you want, and you can distribute it, you can sell it, you can rename it, do whatever you want, but you can't sue me if any of your changes break somebody's account or hurt you in any way. Thing is, though, with MIT, they don't have to give any of your changes. A lot of the time when we think open source, we're thinking, hey, if a big company takes it, they have to give back to the project what they changed. That's GPL v2. GPL v2 is essentially just, hey, you can use my project, you can change it, you can redistribute it, you can rename it. However, you have to give back any code that you add to the project. If you don't, well, that's a violation and we can sue you. Apache is a bit of a medium between those two. It's a bit of a strange one, and I can't really describe it too well. But GPL v2 is my favorite for open source software because it protects it being open source. MIT, Microsoft can just take your project, resell it, and it's now closed source. There's no way anybody else can use that project. It's now closed source. Add back? What do you mean add back? I'm sorry, I don't understand what you mean by add back. Like contribute back? Is that from this text file? Or just from like a... I really don't understand what you mean, sorry. This is my own fault. Give back a function in GPL v2? Oh, yeah, so... Like, sorry. Oh, yeah, I understand now. Sorry, that was my own stupidity. So, like, if Microsoft took Linux, the operating system, well, the kernel, and they added support for Bluetooth, they added support for a specific type of monitor, they now have to make that code available for the people who use it. So they can't just take Linux and now it's Microsoft Linux. And it's theirs now, and nobody else can see the code that they've changed. If they change the code, they have to provide the code back to you. You can say, hey, Microsoft, can I have that code? At which point they have to give you the code back. Meaning that Linux can also take that code, and now Linux has Bluetooth support or monitor support. So it protects it to be open source forever. Yeah, I quite like it personally too. Though there is a use case for MIT, I can see that. I do prefer GPL v2. But if you do prefer it, there's BSD, which currently is utilized on the Apple silicon. Any Apple Macintosh computer will use BSD, or the Berkeley Software Distributor. A BSD licensed piece of software. I really don't like it though because Apple doesn't contribute back to BSD. As I said before, they don't have to give the code back. They can just take the code, and now it's theirs. It's now the MacBook, and you can't do anything else with it. Right. Let's continue reading. Now that you've created an account, saved your API token, chosen a name for your crate, and specified the required metadata, you're ready to publish. Publishing a crate uploads a specific version to crates.io for others to use. Be careful, because a publish is permanent. The version can be overwritten, and the version can never be overwritten, and the code cannot be deleted. If you publish to crates.io, you cannot delete it. You're pretty sure Mastodon had problems with True Social because it used Mastodon without open sourcing it? They did. True Social is currently in violation of Mastodon's license. I believe Mastodon is a GPL v2 or a GPL v3. So is Lemmy. This is a really horrific thing too. No, it's the AGPL. To be clear, Alfaro GPO is just the GPO, everything I just described, but for software as a service. It also gives you a bunch of freedoms as a user that a regular license won't give you. GPL does stuff like telling you, hey, if you utilize this software, the software cannot tell you in order to continue utilizing that software, you must delete other software. So if you use Mastodon, they can't tell you have to delete your bank account. Can't tell you to do that. But yeah, that did happen. And I believe it's still going on. True Social still hasn't open sourced any of their changes. I do hope they do. I mean, really, what piece of value can you get out of something as hateful as that? But still, if they've added anything interesting, I'd love to see it. Also, I'd love to see what kind of random shit they've put in. They probably can't, honestly. They can't open source it. I can imagine True Social has some pretty terrible tracking software just built into it. The code cannot be deleted. Right, so this here is because of LeftPad, by the way. Same with NPM. This guy deleted the entirety of LeftPad, which all it really did was add a bit of space to the to any string. So just add a few spaces before the letter B. Now, millions of projects use this, but the guy just deleted it, took it off of the site, and it was gone, breaking an insane amount of software. So this here, this is because of that issue. One major goal of Crates.io is to act as a permanent archive of code so that builds of all projects that depend on crates from Crates.io will continue to work. Allowing version definitions would make fulfilling that goal impossible. However, there's no limit to the number of crate versions you can publish. Oh, it's a hell of a lot more funny than that, man. Seriously, if you look up the LeftPad drama, it's just an insane situation that happened. Run the cargo publish command again. It should now succeed. And here we go. I'm gonna guess if I looked up guessing game, I'm gonna get like guessing game and then a bunch of random bullshit. Because people were actually following along with this. Congratulations! You've now shared your code with the Rust community, and anyone can easily add your crate as a dependency of their project. Publishing a new version of an existing crate. When you've made changes to your crate and are ready to release a new version, you can change the version value specified in your cargo.toml file and republish. Use the semantic versioning rules to decide what an appropriate next version number is, based on the kinds of changes you've made. Then run cargo publish to upload the new version, or just don't. The Linux kernel doesn't follow any system. When does it update? When does it go from version 5 to version 6? When Linus Torvalds says it does. That's the only way it goes out. Still, though, I wish people would use semantic versioning. React is still in version 0, however. Deprecating versions from crates.io with cargo yank. Why do programmers want to use yank? I've seen this too much. I don't want to yank anybody. Stop that. You know, I've changed my mind. I'm now fully supportive of yanking. Although you can't remove previous versions of a crate, you can prevent this. You can prevent any future project from adding them as a new dependency. This is useful when a crate version is broken for one or another reason. In such situations, Cargo supports yanking a crate version. Yanking a version prevents new projects from depending on that version, while allowing all existing projects that depend on it to continue. Essentially, a yank means that all projects with a cargo.lock will not break, and any future cargo.lock files generated will not use the yanked version. So what you're telling me is that I can just edit a cargo.lock to pretend like it was utilizing beforehand, and still use the broken crate. I'm glad. Yank yump. To yank a version of a crate. In the directory of the crate that you previously published, run cargo yank and specify which version you want to yank. For example, if we published a crate named Guessing Game version 101 and we want to yank it, in the project directory for Guessing Game, we'd run cargo yank verse 1.1. Updating crates.io index. Yank guessing game 101. By adding -- undo to the command, you can also undo a yank. So unyank, you've been unyanked. And allow projects to start depending on a version again. Okay, I'm glad that's not a permanent thing. A yank does not delete any code. It cannot, for example, delete accidentally uploaded secrets. If that happens, you must reset those secrets immediately. I didn't think about that. Yeah, oh no. I imagine if you just, search with some regex for, SSH keys, you'd find an insane amount of stuff on crates.io with just the secrets right there. In just a random yanked code. Can I search for only yanked code? That would be cool. Alright. And now we're going to be quizzed on our knowledge of yanking. Say you're publishing a library foobar v1010. After running cargo publish, you realize there's a bug in one of your functions. Which of the following best describes how to overwrite the publish crate at the same v1010 version? Yeah, it's 3. Can't do that. Nope, you fucked up. Alright. Which of the following steps is not required to publish a crate to crates.io? Adding documentation to each public function in the crate. I don't think that's necessary. Nope. Adding the license, registering and logging onto crates.io, or selecting a crate name that is not registered on crates.io. Yeah, it's the first one here. That would be very funny if you force documentation on people. I think you should. I think this should be a hard rule. You gotta document. 100% coverage. Never gone wrong. Ah, we got it. Crates.io does not allow overwriting of published versions. Best option in this situation is to yank the buggy version and then publish a new one. Shame. Adding documentation to a public function is certainly recommended, but not required by default. Note that if you want Rust to treat undocumented code as errors, you can add the following statement to the root of your library. Deny missing docs. Okay, this is going to be... Could you distribute a version of Rust with this in the preamble? Forced documentations would kill millions. Millions must die. I am okay with that. Look, if we must go back to the Stone Age due to the fact that all of our developers are currently documenting the undocumented code that's been running rampant for the past 80 years, I am okay with it. Millions must die. Okay, here we are. Onto cargo workspaces. Cargo workspaces. In Chapter 12, we build a package that includes a binary crate and a library crate. As your project develops, you might find that the library crate continues to get bigger and want to split your packages further into multiple library crates. Cargo offers a feature called Workspaces that can help manage multiple related packages that are developed in tandem. Oh no, I forgot about that. Oh, those poor critters. Oh no. You know what is worth it for the greater good. Creating a workspace. A workspace is a set of packages that share the same cargo.lock and output directory. Let's make a project using a workspace. Oh, we're going to be doing things. That's not what I want. Home slash. What is this? Rust for lemmings? Right. Let's make a project using workspace. We'll use trivial code so that we can concentrate on the structure of the workplace. Here are multiple places of workspace containing a binary and 2 libraries. The binary, which will provide the main functionality, will depend on the 2 libraries. One library will provide an add1 function, and a second will have an add2. These 3 crates will be part of the same workspace. We'll start by creating a new directory for the workspaces. Vector add cd add. There's nothing in here. Next, In the add directory, we create a cargo.toml file. That will we'll configure the entire workspace. This file won't have a package section. Instead, it will start with a workspace section that will allow us to add members to the workspace by specifying the path to the package with our binary crate. In this case, the path is adder. Alright, so we're just going to create cargo.toml. Here we are. What is going on? Oh, I don't have that? Okay, I don't have an LSB for Tom. I'm okay with that. Alright, in square brackets, we have workspace. Then we have members equaling here, adder. And that's it. Next, we'll create the adder binary crate by running cargo new within the add directory. Okay. Cargo new adder. What does that say? Virtual workspace defaulting to resolver equals 1, despite one or more workspace members being an addition on edition 2021, which implies resolver equals 2. To keep the current resolver, specify workspace resolver equals 1. For more details, see this. What is this? I don't care enough, honestly. At this point, we can build the workspace by running cargo build. The files in your add directory should look like this. Yeah, let's cargo build. Yeah, here it is. Adder, cargo lock, cargo.toml, and target. Okay. The workspace has one target directory at the top level that the compiled artifacts will be placed into. The adder package doesn't have its own target directory. Even if we were to run cargo build from inside the adder directory, the compiled artifact would still end up in add/target, rather than add adder target. Cargo structures the target directory in a workspace like this because the crate and a workspace are meant to depend on each other. If each crate had their own target directory, each crate would have to recompile each of the other crates in the workspace to place the artifacts in its own target directory. By sharing one target directory, the crates can avoid unnecessary rebuilding, creating the second package in the workspace. Next, let's add another member package to the workspace and call it add1. Add1. And I'm just going to assume it's going to be cargo new add1. Well, that's not add. --lib. That's not lib. Wow, I'm doing great today, Andy. Wow. Can I type words into the command line? Is that a thing I can do? Yeah. Looks like it. Good stuff. Right, should look like this now. Does she? Looks like it. Yep, that's correct. It has amended the .get and .getIgnore, but yep, we do look like this. Right, we're going to add something to add1. You're simply going to... I don't care about this. Let's just delete everything. We don't need any of this, right? Add1. X of type, I32. Returning an I32. Alright, it's just X plus 1. That's it. Yep, I'm going to be a rebel. We are returning. So let's tell it to return. Now we can have the added package. Sorry. Now we can have the outer package in our binary depend on add1. First, we need to add the path, a path dependency on add1 to outer/cargo.toml. Right? Here's outer/cargo.toml. Inside of this dependency, we are going to call add1. And it's going to be path. I can't remember what's inside of this. Yeah, I can't remember what can be put inside this. Huh. Cargo doesn't assume that crates in a workspace will depend on each other, so we need to be explicit about the dependency relationships. Next, let's use the add1 function from the add1 crate in the adder crate. Open the adder source main.rs file and add a use line at the top to bring in the library to scope. Then change the main function, call the add1 function as in listing 1470. Alright. So we'll use add1. Why did I do that? There's no reason to have done that. Add1. It's already a module within our project. Good stuff. Let num equal 10. And we're going to print num plus 1 is, and the output here. We're just going to use it. And we are going to have num and num. What? Oh, yeah. Add1 already just adds 1. I knew that was an add thing. Anyway. Oh, that's minus. Wow, thank you. That's good. Let's build it. Do I have this set up? Nope. Right. To run the binary crate from the add dictionary, we can specify which package in the workspace we want to run by using the -p argument. The package name with cargo run. Oh, okay, so that's pretty cool. -p for project, add adder. 10 plus 1 is 11. Good stuff. This runs main.rs, which depends on the add1 crate. I really didn't need to do this. The explanation is enough. I didn't need to type out any of that code. Depending on the external package in a workspace, notice that the workspace has only one cargo.log file at the top level, rather than having a cargo.log file in each crate's directory. This ensures that all crates are using the same version of all dependencies. If we add the rand package to adder/cargo.toml and add one cargo.toml files, cargo will resolve both of those to one version of rand and record that the one cargo.log. And record that in the one cargo.log. What if we're on two different versions? Making all crates in the workspace use the same dependencies means the crate will always be compatible with each other. Let's add rand to the dependency section in add1. Okay. Rand equals 0.8.5. Fantastic. I need that. We can now use rand. We can now add use rand to the add1 source lib.rs file. And building the whole workspace by running cargo build in the add directory will bring in and compile the rand crate. We will get one warning because we aren't referring to the rand we brought into scope. Yep. Let's just do this. Maybe they're going to be doing something important because we just got over closures. Why are we learning at this rate? This is such a drop down in complexity. Yep, if we build, cargo build, we get a warning. Unused rand. The top level cargo.lock now contains information about the dependency of add1 on rand. However, even though rand is used somewhere in the workspace, we can't use it in other crates in the workspace unless we add rand to their cargo.toml file as well. I'm glad. This has to be explicit. For example, if we add use rand to the adder source main.rs file for the adder package, we get this error. No external crate rand. To fix this, edit the cargo.toml file for the adder package and indicate that rand is a dependency for it as well. Building the adder package will add rand to the list of dependencies for adder in cargo.lock, but no additional copies of rand will be downloaded. Cargo has ensured that every crate in every package in the workspace using the rand package will be using the same version, saving us space and ensuring the crates in the workspace will be compatible with each other. Note that cargo only ensures compatibility within the rules of semantic versioning. For example, say a workspace has one crate that depends on rand 8.0 and another crate that depends on rand 8.1. The semvar rules say that 8.1 is compatible with 8, so both crates will depend on 8.1, or potentially a more recent patch like 8.2. But if one crate depends on rand 070 and another on 080, those versions are semvar incompatible. Therefore, cargo will use a different version of rand for each crate. Okay, so if we do have two different crates that have different dependencies, it will in fact download the correct one. That's good to know. I like that that exists. Adding a test to a workspace. For another enhancement, let's add a test of add1 function in the add1 crate. Right. I'm just going to copy this test over. I don't care about typing it out. You know how it does it. We're on add1 currently, are we? Yes, we are. Here we are. Now run cargo test in the top. Yep. Cargo test. In the top level directory. The test, do the test. Yep. The first section of the output shows that the it works test in the add1 crate passed. This next section shows that 0 tests were found in the added crate. And then the last section shows 0 documentations were found in the add1 crate. Right, yeah, I guess test result. Okay, 1 passed. Yep. Here is where it's running from and is getting stuff. Yep, here's the test slash colon 81. It's not exactly obvious what it's testing at what point, though. It doesn't state that this is from the add directory. Who cares, though? You can always just search for the test name. You can also run tests for one particular crate in a workspace from the top level directory using the -p flag, specifying the name of the crate you want to be tested. The output shows cargo test only ran the test for the add1 crate and didn't run the adder crate tests. If you publish the crates in the workspace to crates.io, each crate in the workspace will need to be published separately. Like cargo test, we can publish a particular crate in our workspace by using the -p flag and specifying the name of the crate we want to publish. For additional practice, add an add2 crate in this workspace in a similar way to the add1 crate. Honestly, I think we understand. This is a fairly simple concept. As your project grows, consider using Workspace. It's easier to understand smaller individual components than one big blob of code. Furthermore, keeping crates in a workspace can make coordination between crates easier if they are often changed at the same time. Alright, let's start this test. Consider Workspace with this structure. We got crates A, B. With the following contents in each file. We got crates B, libdirs, with a public function doing nothing. Then A, cargo.toml, takes in B. Which of the following is the correct path to refer to F inside of A, lib.rs? That would probably be B, :F. Yeah, I can't see that being, yeah, it's just B, :F. Yep. Consider a workspace with the 3 packages, A, B, and C. The respective manifests are this. Alright, so we got RAND 8.4, RAND 7.3, and RAND 8.5. We have two versions of RAND. How many different versions of RAND will be used for compiling the packages in the workspace? Right, your answer as a digit. Right, 2. That'll be 2 because we have 8.4 and 8.5, which are completely compatible. However, we have 7.3, which is incompatible with 8.5 by the SEMVAR distinctions, or whatever. Yep, 2. Right, we got that correct. Fantastic. Context, from the perspective of A, B is an external crate like any other. You don't need a prefix to access its items. Secondarily, I think we understand why here. Okay. We've still got a good amount of time. And we're definitely going to get through this very small section. Very simple. Very simple. Those are words that came out of my head. Right. Installing binaries with cargo install. The cargo install command allows you to install and use binary crates locally. This isn't intended to replace system packages. It's meant to be a convenient way for Rust developers to install tools that others have shared on crates.io. Note that you can only install packages that have binary targets. A binary target is a runnable program that is created if the crate has a source main.rs file and another file specified as a binary, as opposed to a library target that isn't runnable on its own, but is suitable for including within other projects. Usually, crates have information on the README file about whether a crate is a library, as a binary target, or both. All binaries installed with cargo install are stored in the installation's root bin folder. Oh, so it's literally just in /bin. Really? They don't have if you installed Rust using rust.rs and don't have any custom configuration, this directory will be home cargo. Okay, never mind. In the Rust installations, not in your distribution or Windows installations bin file. So it'll just be in home.cargo/bin. That's good. That's a lot better than what I thought they were doing. That would mess up system packages. Ensure that directory is in your path to be able to run programs you've installed with cargo install. For example, in Chapter 12, we mentioned that there is a Rust implementation of the grep tool called ripgrep for searching files. Install ripgrep. Sorry. Can't see my face? That's horrible. You can run the following. Install cargo install ripgrep. The second to last line of the output shows the location, the name of the installed binary, which in the case of ripgrep is RG. As long as the installation, that's good actually. Executable is called RG. Usually you don't see that with system packages and stuff like that. I didn't know that. That's really interesting. I like that. If you have multiple executables, will it show it here? I don't know. As long as the installation directory is in your path, as mentioned previously, you can then run rg-help to start using a faster, rustier tool for searching your files. ripgrep is very good. I like ripgrep. Alright, and this seems to be the last one of this section before we get on to smart pointers. Oh no. Extending cargo with custom commands. Cargo is designed so you can extend it with new subcommands without having to modify cargo. If a binary in your path is named cargo something, you can run it as if it were a cargo subcommand or running cargo something. Custom commands like this are also listed when you run cargo list. Being able to use cargo install to install extensions and run them, just like built-in cargo tools, is a super convenient benefit of cargo's design. You didn't know cargo did system binary installation? I've done it before even starting to learn about cargo. I do like that it's an option, though, to be honest, it's not something you really should be doing. Unless, if it's available in your distribution or via Windows or some separate regular way. I'm glad that it exists, just like npm install -- global. Oh, this is it? Oh, by the way, yeah, hi, Megal. Glad to see you. Ah, you're coming in just at the end, in case you've been watching for a while. Laughing at me. That's okay, though. The Language Wars hustle? I have never heard that. Ah, well, we're at the end of this now. We're probably not going to get into Smart Pointer, sadly. It'll be a much earlier thing. Sorry to see that, man. This is just saying sharing your crates on cargo.io is part of what makes Rust ecosystem useful for many different tasks. Rust standard library is small and stable, but crates are easy to share, use, and improve on the timeline, different from that of language. Don't be shy with sharing of code on crates.io. It's likely that it will be useful to someone else as well. Alright. Next, though, smart pointers. I am concerned about this. Oh, yeah, of course. You know what? I support brainfuck, though. I think that can win the language wars. Simplicity is king. You can't see my face. My god. Not that I make... Ah. Just a term you made up? It's sort of why not just always use Rust? Yeah, honestly. I think we should just start killing the other language developers. Oh shoot, we can't say that on Twitch. That's fair. I can't, no. White space is okay, as it can stay. It's hidden. We can hide it inside of brainfuck code and Rust code. I'm really curious how they implement smart pointers. I really want to know. Have you ever used smart pointers, Magel? I don't know what your current programming experience is. We've probably talked about it before, but I don't know if you've ever utilized smart pointers in like C++. That's the only place I've ever seen them. I've never seen the concept outside of it. Nope. Ah, well, you should be here next week. We're either going to see a train wreck in making, or something that I'm going to love to hate. You know, I really hope I like this. Maybe they can do better. I'm just going to read this a little bit here. Pointer is a general concept for variables that contains an address in memory. The address refers to, or points to, some other data. The most common kind of pointer in Rust is a reference, which you've learned about in Chapter 4. References are indicated with the @ symbol. And borrow the value they're used. That's the AND symbol, sorry, the ampersand. They don't have any special capabilities. Smart pointers, on the other hand, are data structures that act like a pointer and have additional metadata. This is just a fat pointer! You've read about how they're the smart tool to reach for over getting into trouble with references, but you don't have intuition for what it ends up looking like. You posted in Lemmy community not that long. Oh, I should read that then. Yeah. Right from this, though, it's making me think that it's not actually using smart pointers in the C++ context. These are just fat pointers. I think, right? These are just fat pointers. Am I remembering fat pointers wrong? I like fat pointers. Fat pointers are perfectly fine. Right, though, I think that this is going to be about it for today. Thank you for dropping in, Magel. I'm going to be reading that. I want to see what it was you were, I would like to apologize. I don't tend to really... Is it this? Anyway, see you guys next week. That is true. I think the proper smart pointer come. They come? I'm glad that they come. I quite enjoy come. Alright, but I think that will be it for today. Boxes, etc. are just fat pointers. Yeah, I'm pretty certain that they're just fat pointers, right? And it was stating that at the end there, that, this... Oh, come later. That is fair. Okay, I am going to start reading on that. I think I got what you were looking at. Is this the thing that you were looking for? That you're trying to oh my god, that just literally showed my actual physical name. Wow, that's a shame. Anyway, thank you for joining in for the last few minutes, Magel. I hope that you have a great day. Talk to you later. That's okay, you'll never see it. It's definitely not live forever. You can't look back at it. Right, see you later. Thank you again for the session. Goodbye. Will you please end the streaming? Why will you not do this? I am good at technology.